as you prepare for finals with the AP, in Calc 1, it doesn't matter. The big thing you got to do in 1 and 2 is you got to get the easy ones. These are some of the easy ones you'll see. And number 1 was just differentiate the function with respect to x. You notice right away that there's no easy way to, you don't want to do polynomial division, do we agree? We don't want to try to divide this. There's no easy way to make it a product rule, so we have to use the quotient rule, where the top is f, the bottom is g. So we take the derivative, and I think if I do this in right, it'll be a little more easy to see. Take the derivative of the top, 4x cubed minus 6x squared minus 4x. That's the derivative of the top, and that's times the bottom without changing it, which is 3x squared plus 3, minus the derivative of the bottom, which I think is simply 6x, times the top, which was x to the 4th, minus 2x cubed, minus 2x squared, all over the bottom squared. Everybody, I'm not going to simplify this because that's algebra 2. In the answer key, PDF that's attached to the video, it shows it both ways. This is probably what I unsimplified if it said do not simplify. If I say simplify completely, it's annoying. If you have to simplify completely, you have to do the algebra, right? And not screw up any signs. All right? That's a lot of work, all right? My temptation usually, if I have this as a multiple choice in the AP, and I had to try to simplify, I might throw a 0 in here and say, well, if I plug in 0, what do I get? And maybe, you should get 0, and make sure if all the derivatives have, then you can say, well, did you pick up the one that makes the 0 as a derivative, because I can see it all comes out to 0. Fundamental, or mean value theorem for number 2, mean value theorem. I'm not going to go through the graph today. I'm just going to say we know it's f prime of c, the instantaneous rate of change of c between a and b is the same as the instantaneous rate of change, right? The instantaneous rate of change is the same as the average rate of change if it's continuous. Is this continuous from 1 to 4? Yeah. This rational function is not continuous at 0. From 1 to 4 it's continuous, so the mean value theorem will work. So I need to do 2 things. I need to find the average rate of change, which means find, and I'm going to change y to f of 1 and f of 4. And when I get those values, that's f, and b is 4, and a is 1 for that equation. If I plug in 4, I get 16 minus 4 is 12. 12 divided, is it 1? And I plug in 1, oh, negative 3 over 3 is negative 1. Oh, yay. Oh, joy. All right? So, does that look right?
Yeah, those are values depending. Because it
So,
0 as the average.
Did I make a math mistake on the 1? All right. So there it is. That's the average rate of change, which is 2/3. You guys agree? All right. Now, that is equal to the derivative of this. Everybody, 2 ways to do this. I'm going to do it this way. I do not want to do this as a quotient rule. Does everybody agree I can rewrite that problem like this? Right? And then I can rewrite this problem like this. Everybody, I much prefer to take the derivative of the second thing I wrote here versus the very first thing. I don't want to use the quotient rule. I hate the quotient rule. You should hate it too. And when we can simplify, we can do this. So, y prime, I think, is 1/3, right? Because derivative of x is 1, plus 4/3 x to the negative 2. All right? And I know that I'm going to get rid of this. I know that's equal to 2/3 because I know the average rate of change on that interval is 2/3. So I say, hey, I'll plug in c, 1/3 plus, and I'm going to put the c on the bottom again. This is a lot of me jumping around with exponents. X negative 2, or c negative 2 to be in the bottom. Move 1/3 to the other side. And I get 1/3. 3 3's both in the bottom. You guys agree? Cancel the 3's. Multiply both sides by c squared. 4 equals c squared. So c is plus or minus 2. But I can't say that's the answer, because my interval is 1 to 4. What's in the interval? 2. Just 2. Not plus or minus 2, even though that's what it equals out to. So c is 2. Find the value of c. The value is 2. All right? That is where the instantaneous rate of change of the function equals the average rate of change over the interval 1 to 4. So f prime 2 equals the average rate of change of the interval 1 to 4. All right? Mean value theorem. And again, that's just like a little rote problem, right? Plug and go. All right, number 3, given the graph of f of x, sketch the derivative. All right, I do it the same way every time. Find those zeros. They're powerful. I see a 0 here and here, right, at the local max and min, 2 critical points. Plot those points. Boom, boom. At 2 and between 0 and -1. So if I want to make it over here, because I have to do it here, I'll replot them over here. But I'm going to work on the left one. I see it's decreasing between my 2 red points, right? It's going downhill here. So it's negative. I see it's increasing and increasing, so it's positive. There's my graph. And everybody, again, from your pre-calculus days, when I erase all this stuff, this is a cubic, right? So y equals x cubed, and it's shifted, right, up, down, all around. But the highest order here, this is definitely shaped like a cubic. Derivative of a cubic is a quadratic. So it's a parabola. You know, it's shifted, but that's the looks of it. All right. So again, you know a lot by using both rules. All right. The last one today, kind of keep us running and getting warm. A couple ways to do this. If you're getting well practiced, you can probably just see that the derivative of the inside is part of that, okay? But I'm going to step through that we can't integrate sine of stuff. We can only integrate sine of x, or sine of u. So we're going to set the stuff equal to u. And immediately say, hey, du is what? 8x cubed? Well, I have this stuff. I know I need the x, dx. Sorry, I forgot my dx. I know I need the x cubed and the dx. I also need a coefficient of 8. So everybody, just make it kind of stand out. I'm going to pull up to -16 and do a little reorganization here, okay? I'm not going to change anything yet. But does everybody see what I just did? I just kind of reorganized everything. We have a rule, bring coefficient out. Well, I need an 8 here. If I put an 8 there, I have to divide by 8. You guys agree? Because 8 divided by 8 is 1. I can multiply by 1. And now I can make a big jump. And my big jump is this. I can write -2 integral sine u. This is all du. And hopefully you've done enough integration practice where you don't have to do this too much. I always think of it this way. I'm picturing these in my head really fast usually. And I see I have sine x, and I know I got to go backwards. So I quickly picture this, that switch, so I know the derivative, the antiderivative of sine x is cosine x. So I write negative cosine u plus c, and then I know what u is. U is 2x to the 4th minus 1. So now I can do this. 2 negatives make a positive. So up here I can write this is equal to 2 cosine 2x to the 4th minus 1 plus c. And if I really want to make sure I'm right, take the derivative of the blue, and it will be the black. All right, have fun at Justin Beamer. All right, and everyone else, keep studying your calculus.